Well, the essence I wanted them to take was the following. We've got all these data, got all this data, this enormous collection of sequences and lots of other things. We have a huge industry now of people publishing papers, and the whole thing is now just getting buried because no one can make sense of it. So my message is what we've got to do is find ways of converting this data into knowledge, which is very different from just plain data. That means you've got to organize it. And when people say, how can we understand this? What you have to do is, that is what knowledge gives you, is understanding. So you could ask yourself the following. Could we look at a genome and say, my God, that's a zebra? Could you see that in a genome? Could you compute the organisms from the genome? And of course, it's not even a program, it's a manifesto. Okay, so it says you could reach a lot of understanding of that if you could do this. You see, now let me give you one example, which I think, so I have these two very closely related hominids. Okay, there's the one guy who actually is suffering from a disease, and the disease makes him look like a chimpanzee, right? And the other guy is any one of our friends. Right, now, I go to all these experts and I say, can you tell me which are the genes in the chimpanzee that I must change in order that he can no longer have this terrible disease, that he looks like a chimpanzee? And of course, it's asking the question in a funny way, because really what we want to know is, you know, what is in us? What are the genetic changes in us that have given rise to the differences? And I think that that is the most challenging problem of biology. It's going to keep us occupied for a long time. But in order to do this, you see, I think one example I like to give for this is in fact the following. You could have said, and people use the word gene very badly, you could have said, well, when we've got the chimpanzee genome and we've got our genome, we're going to find one extra gene in us. It's going to be the gene for language, you see? I mean, this is the crude way of looking at it. But you see, there's another thing that might have happened, which you can't tell, which is that maybe chimpanzees found that talking gets you into trouble. So they evolved a language suppressor gene. To survive, don't talk, all right? Now, that means the extra gene in this sense would be in the chimpanzee. Now that makes extra sense, because if you look at what constitutes language, it's a huge number of changes. You know, we have to change the tongue, we have to change the larynx to get words out, we have to change the brain, we have to do a lot of things. So there cannot be one unitary thing that acquires language. On the other hand, once it had evolved, you can kill it with one event. You can just cut off a piece of it, it won't work, you see. So I think people have to really understand before and they now talk about genes for schizophrenia, genes for autism, genes for alcoholism. That, I think those are all nonsense things, you see. You can't have a gene standing for a state like this. So I think that what is needed, and especially in reference to animals like you and me, we need really to think out exactly what the genome does. Now, for example, just to revert to the chimpanzee thing, right? The one thing you can see different is our feet and chimpanzees' feet. Chimpanzees' feet are like hands. When chimpanzee walks, he walks on his knuckles. He doesn't walk on the palm of his hands. All right? And we know from hominid skeletons that have been found, we can see the evolution of the bipedal state, to walking on 2 feet. As a lot of things have to happen with your spinal cord and the way your head is screwed onto it. But nonetheless, we could take as a project, let's try and find out what happened to that you could evolve from a hand into this rather specialized form of it, the bipedal foot. And I think that's something that we could do. It's going to be something to do with the development. So we know which genes participate in this. And we could actually then test whether these genes work for longer during development or for a shorter time. But until we construct that, it's going to be very difficult to understand exactly how you transit between different animals in the evolutionary pathway, and also in trying to understand what keeps us going as a going concern, and that, I think, must drive people away from the easy fix. I'll just do all this, I'll just collect all this data and it will emerge. You actually have to have a theory, and you actually have to test it rigorously. And what I fear is that with the rise of this, very large labs sort of cranking away at sequences, that is going. And I also think that, scientific generations change very quickly, about every 3 years, every 5 years. And of course, the modern generation now has a different view of science than, let us say, all our guys who sort of trekked across the territory with horses, basically, whereas these guys are driving, Mercedes on high-speed autoways. And I think that this is not a good way for science to develop. Well, let me tell you, a lot of the things that have been accomplished in science have been accomplished on the basis of ignorance, in the sense that you import into the science people from outside. Because once you have an established science, it's got its high priests, the guys who know everything that will work or won't work, and they don't want to be bothered. So you have to have a challenge. And the great thing is that young people are ignorant, and we should catch them before they turn into the priesthood. So I think that science needs to have a much more daring approach. And I think one of the problems is everybody is now averse to risk. Nobody wants to take risk. And I'll tell you an interesting story to illustrate this. I once went to a pharmaceutical company whose name will go unmentioned here, but I offered them a program of research, and I asked them in Britain what was the equivalent of $100,000. That is, I give them the program, they give me this money, and I can use the money for something else, you see. So one of the people in the company says, how do we know it'll work? So I said, look, if I knew it worked, I'd be asking you for $10 million. Okay? So think how much money you're saving by sharing the risk. It's called research. Research is a risk. If it works, we hit the thing. If it doesn't work, well, we set it aside and start again. So you have to have that series of things. If we knew it worked, we wouldn't bother to do it, basically. So to meet the challenge, I think you've got to support young people, and young people who are prepared to take a risk. Because that's, what a lot of us did, went into a brand new field. Now, of course, that's, tampering with the sociology of science is very, very difficult. Because I came recently to the conclusion that what we need to get rid of in science is the middle-aged. And it's based on a very human thing that I'm sure some of you know, is that grandparents get on with grandchildren. The problem with all families are the parents in between. So I think we should just get rid of them in science. And just have, old guys like me and a lot of these young guys. Then I think we'd do it. Of course, somewhere we've got to ensure a supply of grandparents, and somewhere we've got to secure a supply of children. So we'll need them, but I mean, culturally, we need to have a different kind of exchange of knowledge. There's a big now discussion on mentoring. You see, so most people who supervise students are tormentors rather than mentors. And part of it is the structuralization of everything has to be done with meetings, group meetings, everything is done in a formal way. And there's nothing to beat one-on-one. And I've always viewed science like a medieval guild, because it's a craft. It really is a craft where you have young apprentices learning the trade from skilled journeymen. And you hope that they are the ones who are going to change the world in the future, and that's why we must nurture them. So I think we should do this. There are lots of schemes that have been put forward, to try to shift the balance. But as you know very well, the power resides in this, because old people are just thrown away, they're useless. And of course, young people are inexperienced and don't know anything. So it's all the people in the middle career who are the people that decide things.